Hello, in today's chemistry lesson, I'm going to study the topic 9 Redox process. And this MC question is from IB past paper, May 17, time zone 1, question 21. And the question is about the activity series. What's the order of decreasing reactivity of metal? So most reactive first. And there are 4 different equations. So before talking about this MC question, I want to look at the activity series in the data book. So even though in your IB paper 1 MC question in chemistry, data book is not provided, right? Only the periodic table is provided in the first page. But I want to explain the concept of activity series here. So we can see that there's a list of an element here. Increasing reactivity. So the higher metal is more reactive than the lower metal, right? So I take 2 very extreme cases, lithium and gold, the first and the last one. So among all these species, lithium is the most reactive. So I can write the equation like this. Lithium, so metal reactive or metal is reactive means metal tends to lose electrons. So losing electron is an oxidation, right? So lithium is an oxidized to lithium ion and losing electrons. But I can write the equation using an equilibrium like this. Just 99% oxidation and 1% reduction. I can say the lithium ion is very stable, it's hardly to going backward. So yeah. And for gold is very stable, very unreactive, right? So which means the gold ion is very reactive, right? I undergo reduction going backward, right, to form a gold metal. So because gaining electron is a reduction, I can say that's a very strong oxidizing agent. Yeah, the same. You can imagine it's a 1% here and then 99% backward. So one more thing. Yeah, lithium is the strongest reducing agent among all the species here. Yeah. So the Redox equation is like one reactant undergo oxidation and the other one undergo reductions. So now we can conclude that the lithium react with gold ion to form a lithium ion and gold, right? Because one undergo oxidation and the gold ion undergo reductions, right? So that's perfect. I'll just use one sentence to conclude the concept of activity series here. So that is, the more reactive metal can reduce the ion of less reactive metal. So yeah, the more reactive metal can reduce the ion of less reactive metal. Or I can say the higher position metal in the activity series, okay, can reduce the ion of the lower metal. Yeah, the lower metal. The higher metal can reduce the ion of the lower metal. Yeah, let's say, I'll just pick some metal as an example. So lithium can reduce the magnesium ion. So because lithium is higher than the magnesium, right? So lithium can reduce the magnesium ion. So lithium is oxidized to lithium ion, and magnesium is reduced to magnesium. So balance equation, right? 2 and 2 here. The charge, you have to balance the charge, not only the atom, right? So one more example. Let's say magnesium and zinc, right? So magnesium can reduce the zinc ion. Yeah. So magnesium is oxidized to magnesium ion, and zinc ion is reduced to zinc, right? Like this. So let's go back to this MC questions. So there are 4 different equations, and we can make one conclusion in each chemical equations. So the first one, zinc react with a tin ion. So if there's a reaction, that means the metal is more reactive than this tin, right? So we can conclude that the zinc is more reactive than tin. The second one, copper cannot reduce the zinc ion. So we can conclude that zinc is more reactive than copper. The third one, tin can reduce the copper 2 ion. So we can conclude that tin is more reactive than copper. Yeah, last one, silver cannot reduce the tin ion, right? So that means we can conclude that tin is more reactive than silver. So zinc is the most reactive. So not B and not C. Yeah. And then tin and silver. Silver is the least reactive metal. And yeah, tin is more reactive than copper, so it's D.